Most mobile apps fail not because of UI, they fail because the architecture can't scale. Today, we will explore advanced architecture patterns that power apps used by millions. The event-driven architecture. What is it? Instead of components calling each other directly, they communicate through events. For example, user sends message, event, message sent, notification service lessons, analytics lessons, and sync service lessons. No tight coupling. In mobile context, inside your application, the view model emits a state, and UI observes changes, and on backend services publish events to message broker. Other services consume asynchronously. Popular backend tools like Apache Kafka will rapid MQ. The benefits: loose coupling, scalable, real-time updates, easier feature extension. Reactive architecture. Reactive systems respond to data changes, user interactions, network updates. Instead of pulling data, we subscribe to streams. Let's take a mobile example. Kotlin Flow RX Java combined in iOS UI automatically updates when database changes, network response returns, background sync completes. Core principles. Reactive systems are responsive, resilient, elastic, message-driven. From the Reactive Manifesto. Microservice-driven mobile backend. Instead of one huge backend, we split into services: authentication service, chat service, payment service, notification service, and each service independent deployment, own database, and own scaling rules. It used by companies like Netflix, Amazon, and more. Why it matters for mobile engineers? Because your application must handle partial service failure, retry intelligently, fall back gracefully, support versioning. Mobile must assume backend services are distributed. CQRS, Command Query Responsibility Segregation. It is a very powerful pattern which separates commands to modify data, queries to read data. For example, in chat application, the command will send a message and the query will get the messages. Why separate? Because write model optimized for consistency, real model optimized for performance, often used with event sourcing distributed systems. How it works: write to local database first, update UI immediately, sync with backend in background, resolve conflicts if needed. This makes app fast, reliable, and user-friendly. Conflict resolution strategies: last write wins, version-based merge, server authority, and manual resolution. Architect must decide based on business rules. Combining all patterns together, let's design a fintech super application. For example, mobile, offline first, reactive UI, event-driven state, and backend microservices, CQRS, Kafka event streaming. The flow: user will pay, local database updated, and UI reactive update. Command will send to payment service, event published, notification service reacts, analytics reacts, and read model updated. Mobile syncs automatically. That's a real system design. The senior engineer thinking when designing advanced mobile architecture will ask, can this scale to 10 million users? Can services fail independently? Can we deploy without downtime? Can app work offline? Is data flow reactive? Architecture must survive growth. Common mistakes: over-engineering small apps, using microservices too early, ignoring offline strategy, blocking the UI on network, no retry or fallback logic. Advanced architecture isn't about complexity. It's about scalability, resilience, performance, maintainability, and real-world reliability. If you master these patterns, you will be a hero. Thanks for watching and see you next video.